Hi friends, good morning to everyone. Have you gone through the last session materials and the video? Have any doubts?
Sir, your voice is too low, sir.
Have you gone through the last session materials and video? Have any doubts?
No doubt, sir.
What about others? If you have any doubts, right, first ask me. Okay, in this session, right, first now we are going to see what is a symbolic constant. Symbolic constant. Symbolic constants are constants defined with some initial values so that we cannot change the value of a symbolic constant. Symbolic constants are defined using a hash defined preprocessor directive. Hash defined a preprocessor directive. I write here hash defined. This is said to be a preprocessor directive. After that, we need to define the constant name, then constant value. So once you define the constant name along with its value, wherever we need in the program, we can use that constant name. For example, here hash include stdio.h hash define hash define, right? This is the preprocessor directive. Hash define, this is used to define a symbolic constant. For example, we define hash defined by 3.14, 3.14159. Hash defined strength, say 60. So wherever we need a variable pi, you need not worry about its type and all. Its numerical value is associated. 3.14159. So clearly a floating point value. Pi is said to be a constant. Wherever we need, we can use the value of pi. Wherever we need a variable strength, the variable strength is set a constant value 60. All these preprocessor directives are symbolic constants should be defined before the main function section. So before int main, define these preprocessor directives. For example, here I write float radius r. I write float area is equal to pi r square pi star r star r, so that we can print out hash area is equal to percentage f comma area. Likewise, we need to print the value of strength. Print out slash n strength is equal to percentage d comma strength. Pi, this is a symbolic constant. We are just calling that name wherever we require in the program. So the highlighted place pi, this is replaced with this value 3.14159. Next, if we like to find the circumference is equal to 2 pi r, 2 into 3.14159 into r. So whenever we need a constant, that constant is repeated or required multiple times in the program, it is better to define that as a symbolic constant. so that wherever we repair, we simply use the name of the constant. Ultimately, the value of the constant is replaced, right? So whenever you define a constant, you must set the initial value. Let us check the code file, save. I think the next file name is CP17 F9. No compile time errors. Finally, if we need, we can give a return 0 as usual. Control, control F9. Yeah, area is pi r square, right? What is r? R is not initialized. Let us initialize r is equal to 2.5. For example, control F9. We are getting the area compiler F9. What happens? Expression syntax in function main, because strength is defined a constant, initial value must be set. For example, I like to fix a class strength 60. Wherever I need a variable strength, I can access the value 60. So whenever you define a constant, constant name space values should be set. Second thing, we can use the constant any number of times in the same program. The third thing, whatever you defined as a symbolic constant, you cannot change its value. For example, I write strength is equal to, or I try to write strength plus plus. What is the effect of strength plus plus?
61, sir.
What is the effect
Post
of
increment.
post increment? It increments the value of strength by 1 that we are expecting, but compiler reports the error message. What is the error message? L value required in function main. That means you cannot try to modify. For example, strength is equal to, I update 62. In this case, what happens? Again, same message. L value required in function main. That means some left hand side value is required, but the strength is defined as a predefined constant, right? You cannot change its value. So here I write error since strength is a symbolic constant. Since strength is a symbolic constant, you cannot change the value. STA. Okay. Since strength is a symbolic constant, you cannot change its value. Understand? Understand or not? You can define any number of symbolic constants here using hash define as a preprocessor directly. This is also acceptable, right? Hash space define control F9. Okay. Hash, right? No space or hash space, right? Whatever is accepted. Have any doubts in this? Based on the requirement of the problem, whenever we need some initialization, fixed initialization, so that the value of that variable, right, should not be modified, altered, and you need not declare, right? No need to declare its type also. Because of the value of that constant, the data type is accordingly taken. 3.14159. So floating point value is taken. 60, right, an integer 1. So strength, right, this can be taken as the integer 1. Next, before going to the control statements, we need to revise, we need to write, discuss, right, some topics. we need to revise, right, the variable declarations. Variable declarations. Suppose we want to define a variable uh, with one integer type, we can define this as integer x. In case if we want to define two variables, we can use int x comma y. Suppose we want to store the marks in 25 different subjects. We can write int m1, int m2, int m3, int m4, etc. We need to write m25 or m60. For example, the particular subject mark, right, for 60 students. Mark 1, Mark 2, Mark 3, Mark 60. Or one student, right, mark in 60 different subjects or 60 different tests. In this case, it is difficult for us to define the variables like this. M1, M2, M3, M4, right? All should be defined explicitly. We cannot use a triple dot like this as we do, right, in mathematics. This is not acceptable. So it is a tedious, right, as well as a difficult task, and to define the variables and to maintain the variables, right, that is also a difficult task. In this case, just to have the variable declarations part m1, m2, m3, etc., m60. This can be replaced by using a concept called array. Array. So what is an array? Array is a collection of similar types. Array is a collection of similar type. M1 is an integer type, M2 is an integer type, M3 is an integer type, etc. M60 is an integer type. Instead of having the variables like this M1, M2, M3, etc., M60, let us have it reasonably as int m of 60 semicolon. In this case, m of 60, right, this is the array declaration. M of 60 means we need to understand two things. Int m of 60. First, m is said to be the array name. M is the name of the array, which is of type integer type. Second thing, 60, which defines the number of memory locations. Number of memory locations that you need to think as of now as the number of variables. You can think of these variables as m1, m2, m3, etc., m60. So conveniently, we can access the particular index m1, m2, m3, right? Mathematically, right? We can access as mi 1 less than or equal to I less than or equal to 60. The same way here, we need to write m of I is equal to some initial value, for example, 0. So if we write m of I is equal to 0, that means m of 1 is equal to 1, m of 2 is equal to 2, etc. We can access the 60th variable. For example, I write m of 60 is equal to 60. So instead of writing m60 is equal to 60, m48 is equal to 48, it is more convenient to represent using this subscript notation. This bracket, right, this is to be the subscript operator or subscript notation, opening parenthesis and a closing parenthesis. What is here m? M is the array name. M is the array name. 1, 2, 3, etc. 60. These are said to be indices. Another name for indices is subscripts. So m of I, m of 1 is nothing but index. 2 is the index value. For example, the variable m60 we have, right, the index 60. 60 is the index value. Conveniently, we can access a particular index using this representation. Array name bracket, then we can specify the index. The index, right, that defines what is the location in the array, right, to be accessible. Normally here if you define 60 means array size is 60. If you define int x of 5 means array size is 5. That means here 60 means 60 memory locations, 60 variables can be accessible. 5 means 5 variables can be accessible. For example, I write in short, instead of having int x1, x2, x3, x4, x5, we have a simple array declaration int x of 5. That means x is the integer array which consists of 5 locations. We can fix our own locations. Conveniently, right here, the locations or indices are assumed to be 0, 0, 1, 2, 3, 4. So this is nothing but mathematically x0. This is x1. This is x2. This is x3. This is x4. Right? The value at the 0th index is simply x of 0. Value at the first index is x of 1. Value at this 4th index, this is x of 4. So once you define the array like this, you can subsequently assign the values. X of 0 is 1, x of 2 is 12, x of 3 is 14, x of 4 is 18. I am randomly assigning some values. What is missed? X of 1 is missed. Okay. X of 1 is 10. So 0, 1, 2, 3, 4, 5 indices are fixed because of the array size. Here this is the size of the array. Size of an array. After 5 indices, you cannot take any other index. It is not necessary to have the indices 0 to 4. Conveniently, we are taking the indices 0 to 4. Even you can fix, right, any 5 indices as positive integers, right? Even, right, you can include 0, x of 25, x of 48, x of 90, x of 100, x of 27, like that. But once you fix any 5 indices, you cannot fix the 6th index, right? This is a way to define the array just to eliminate, right, the multiple variables. We are representing the array using this general form. Data type, array name, then within bracket we need to specify the size. This is said to be a one-dimensional array. As of now, just to have an idea what is an array. Array defines the collection of similar type. So when multiple variables are of having same data type, like x1, x2, x3, etc., x100, it's difficult for us to maintain these variables. It's difficult, right? We can write x86 is equal to something, x97 is equal to something. Instead, x of 96 is equal to, x of 67 is equal to, or x of j is equal to, where j ranges from 1 to 100. For that purpose, we need to learn, right, the concept of arrays. So as of now, right, just to have the basics in variable declaration, how this kind of variables are replaced using more about arrays, right? One dimensional array, two dimensional or multi-dimensional arrays, we will explore later. So just to have the basic concept of array, array is defined as the collection of similar type, that is same type, integer, integer, right? Float, float, float. All float can be simplified into a single array as a floating point array. Have any doubts in this? Okay, the next one that we are going to discuss here, the concept of right library functions and how to get the character inputs. For example, here character input output operations. Hash include stdio.h int main. They have explored several data types supported in a C language. Float, integer, long integer, signed int, unsigned int, short int, etc. Likewise, one important data type is char ch. Char ch is equal to small x. Then we can define another character, say char ch1 is equal to x, comma ch2 is equal to capital T. What is char? Once we type char, right, this is highlighted. So this is a keyword. You can print the value of these character variables ch1 and ch2. I write print /n ch1 is equal to percentage C. Now you need to note it to process or to perform character IO operations. Percentage C, C for character, format specifier is introduced. ch1 is equal to percentage C, ch2 is equal to percentage C, comma ch1, comma ch2. So in this example, we have defined two character variables, say ch1 and ch2, and we tried to print their values using a printf statement. File save cp18 f9 control f9. ch1 is x, ch2 is e, because these are characters. Any character, right, that we are going to initialize should be enclosed in single quotes, opening single quote and closing single quote. This is opening single quote, this is closing a single quote. In case if you want to find out the equivalent ASCII values, we can print character to integer conversion. ch1 is equal to percentage d, ch2 is equal to percentage d, comma ch1, comma ch2. Percentage d, right, now what happens? The character is printed with respect to its ASCII value, because every character, right, is associated with the numerical value. That numerical value is ASCII value. I have already said, right, you need to remember these ASCII values. Capital A to capital Z, what happens? 65 to 90. small a to small z, 97 to 122. So we printed, right, small x and capital A, it says small x is, right, 120, capital A is 65. This is the character output operations. In case if you want to receive the character inputs, here we can use the scanf statement. For example, printf character ch1, ch2, then have another variable, comma ch3. Printf slash n, please enter the character. You can get input using scanf statement. Scanf, what is the format specifier? Percentage C, percentage C, ampersand, ch3. We can print of slash n, ch3 is equal to percentage ch, comma, percentage c, comma, ch3. We are trying to get the input for the third character variable ch3 through keyboard. I am running the code, control F9, ch1 and ch2 are initialized and the values are printed. Enter the character. For example, I define a character, right? For example, 0. 0 is also the character. ch3 is equal to 0. If you want to print the equivalent integer value, you need to write percentage d format specification. I write ch3, comma ch3. In this case, control F9, I enter character 0. 0, right, equivalent ASCII value is 48. 0 to 9, right, 48 to 57. These are the ASCII values corresponding to the digits 0 to 9. Control F9, I write another character, say capital Q. ch3 is capital Q and the associated ASCII value is 81. So keep in mind that to process character input output operations, in the printf statement we need to use percentage C format specifier, and in the scanf statement we need to use percentage C format specifier to accept a character. To initialize a character, use within single quotes only one character should be specified. Have any doubts in this? Have any doubts?
No, sir.
Okay. Next, right, we need to learn, right, a few functions. The functions that we are going to see, right, with respect to char operation, character operation. Please take the function names getChar and putChar. getChar and putChar, these are the functions already defined in the header file stdio.h. Let us illustrate, right, getChar and putChar. getChar is a function which is used to read a single character from the keyboard. Already in the previous example, we have seen scanf percentage C ampersand ch3. The equivalent simplification is simply use getChar. For example, int main printf slash n, please enter a character. character, let it be char ch. Please enter a character. Ch is equal to, we use a function get char empty parenthesis. Then printf slash n character is percentage C. We can use the equivalent, the putchar function, RACTR, character is percentage C at CH, return 0, F2 has 5 CP19.
Sir,
Yes,
sir, character as in only one letter, sir, or can we write a full sentence, sir, for this?
one character, just
Oh,
a single character.
okay, sir.
Whatever you have in your keyboard, A to Z, 0 to 9, then some special characters, less than, greater than, dot, comma, question mark, plus minus star, like that, right? A single character. In this example, right, char ch is a character variable. We do like to enter a character. Get char function, right? Let us check its effect. Control F9. Enter a character. For example, I take a capital X and pressing enter. What happened? Ch is equal to get char. Get char is a function which is defined in a header file stdio.h. If you want to check, right, the equivalent, right, help for a built-in function, that is a standard function. These are said to be standard or inbuilt, we can say inbuilt or built-in functions. Now let's see. To learn a help for getchar function, you can place the cursor right anywhere in between getchar. Press Control F1. Yes, press Control F1. After that, right, you can see this one. Search for getchar. Keywords found: getchar, turbo C++ help. Same for both C and C++ version. Getchar. Double click. You can find. This is the syntax for getchar function. Getchar void. You need not worry about, right, this return type and void and all. Simply, the function getchar is defined in the header file stdio.h. We have included stdio.h. Getchar, right, simply reads, gets, receives a character from the standard input device, which is defined as stdin. So whatever the character that you are giving, the character is received in some variable, right? We can use left hand side variable, for example, getchar. Another one is putchar. Control F1, pick any one. Putchar into C. That means integer value can be put or the equivalent. Character, right, can be defined. Putchar, right, the character variable. What happens? The character is printed, right, using the percentage C format specification. So here, have a look into, right, this outcome. It seems strange. Don't have any confusion. Enter a character, ch is equal to getchar. This is similar to a scanf statement. I write here scanf, what one? Percentage C ampersand ch. Alternately, ch is equal to getchar is equivalent to a scanf statement. Scanf percentage C ampersand ch. Likewise, printf character is percentage C putchar of ch. What happens? Up to this you need to learn. Put care of ch means the current character ch is going to be output. So to output a character, here we use percentage C format specification, right? So that it seems the result is character is colon percentage C, right? This is retrieved from the output put care of ch. So this is simply equivalent to a printf statement, printf percentage C, comma a ch. If you try to give put care ch, this is also fine. Simply it outputs a character. Char ch, right? Simply this is equivalent to printf percentage C, comma ch. The equivalent role is obtained using a built-in function because functions are already defined to process a single character. So we can use getChar and putChar functions. We can ask how this is working. PutChar of ch. PutChar of ch, right? Simply outputs a character to the standard output device. There is no change. But here putChar of ch means whatever the character you typed here, that is printed using percentage C format specifier. So the direct usage is getChar, right? Ch is equal to getChar necessary because the input character should be assigned to the one variable, right? Ch. Ch is equal to getChar. If we try, right, simply using getChar, what happens? Control F9, enter a character J, some other characters are printed. Simply getChar, no problem. It reads a character from the keyboard. Yes, it read a character capital G. But putChar of ch unnecessarily printed some garbage value. Garbage value means any value, right? In the second run, right, you can expect some other values. In different compilers, you can expect different outputs. But when getChar is used, right, carefully introduce the left-hand side variable so that whatever the character that is read from the keyboard should be assigned to the left-hand side variable. And the simplest usage of putChar is this one to simulate, right? Printf percentage C ch. We can also use a putChar statement like this. This is for processing a single characters. In case, as you asked, for example, if you would like to process multiple characters, I do like to read more than one character as the input, and to print more than one characters as the output. That stage, the alternate to getChar and putChar are getus and putus. GETS and PUTS, putus functions. These are also standard functions or built-in functions defined in the header file stdio.h. TETS, this should be read as gets, right? PUTS, right? Puts are a puts function. The purpose is here to read more than one characters from the keyboard and assign it to the variable. So what type of variables are supported here? We need to define as a string input. So to process the string input, hash include stdio.h int mail. We can use percentage S format specification. Printf /n, please enter mail. Use scanf statement. scanf percentage yes ampersand name. Here name should be defined as a character array. Character name of, for example, 50 characters. Name is a character array which receives more than one characters because collection of characters, right? That is to be a string. Here what is name? Name is a string type. String is implemented as a collection of characters. Next we can print the value. Print percentage yes, comma percentage yes, comma name. Return 0. We have to file, save, TP20, F9, no compile time errors, control F9. Please enter name, for example, India, and gets printed. So we have seen percentage D integer, percentage F floating point 1, percentage C character input output operations. Finally, we have seen percentage S. This is for string input output operations. More than one characters are given as the input. In this case, for example, control F9, I give the name New York, new then space York, pressing enter. What happens? Scanf statement reads characters until the blank space is reached. Spaces, blank spaces are reached. New space. So the space YORK will not be assigned into the variable name.
Sir,
That is the problem with scanf statement.
sir,
Yes.
sir,
Yes.
this gets function and puts function can be used for any data type, or it's only for char function, char data type.
Care function. That's the thing, right? Next we do want to show.
Both, sir, get
In
char function
scanf
and
sta-
get function also is used for only for
get
char data type.
character. Yes, get care, put care, get us, put us, right? The purpose is only for string operations. So in this example, percentage yes reads the characters until the blank space is encountered. Continuing space, no characters are accepted into the variable name. So to resolve this issue, we need to use the functions getters and putters functions. Let me modify the code, copy, file new, edit, paste. You can perform right copy paste operations easily in this editor. Here, okay, yeah, getters and putters functions, character name of putty, please print up slash and please enter the name. The scanner statement, this is replaced by shift delete, getters name. Print up percentage is name. This is simply deleted, right? And use putters name. That's all. Let us check the code. File, save, CP21, F9, control F9. Please enter the name. New York. Getters name. What happens? Getters is the function. The parameter to the function is name. Notice it carefully. Here name is a character array. Since we like to get more than one characters into the character array, getters function must take a parameter which is of a character array type. So character array name is name. Name is given as the parameter here. Name, get us name. So get us name, right, reads a line of text, right? Maximum here 50, which indicates that 50 characters are read and assign it into the variable name. To print, right, the number of characters assigned and the values, you need to use the putters function. Putters get us, right, defined in stdio.h. Simply the value of the string constant defined in the character array name gets printed. New York. For example, I type enter name 1, 2, 3, 4, 5. What happened? Putter's name, right? 1 space, 2 space, 3 space, 4 space, 5. So it accepts, right, 50 characters, right? So once it exceeded the 50 characters, then the input is dropped, right, and rejected. Only the first 50 characters are taken into this character array variable called name. Understand or not? Here the advantage, what is the advantage? Blank spaces are accepted in the input, where when we use percentage yes, right, and the scanf statement, that once the blank space is reached, that is the termination for the current string input. So to have blank spaces in the character array names, we need to use on these functions, getters and putters functions. Have any doubts in this? Have any doubts?
No, sir.
Okay, now let us solve the problems, right? Solve the problem, right? We need to load the control statements. Already, right, we load the control statements, right? If else, if, right? So based on that structure, right, let us solve the problem. File new. Can you please take the problem? Write a program to find the minimum of 5 integers using if else statement. If else statement. 5 integers, right, should be given as the input. So include header file hash include stdio.h into main 5 integers. For example, I write int a, b, c, d, e. We can also use the concept of arrays. So as of now, right, don't worry, right, we will explore more about arrays, right, later. Print hash n, enter, please enter 5 integers. The core part in C programming is, right, control statements, conditional control statements, unconditional control statements. So in this session, right, let us solve this problem, right. In the next session, right, we will focus in detail, right, what are control statements, what are conditional control statements, unconditional control statements. So we need to go through, right, if else, right, a nested if else, right, then for statement, while statement, do while statement, switch statement, then unconditional control statements, break, exit, go to, right, return. We need to explore all these, right, statements with examples, right, then only we will be able to solve the problem. So as of now, right, just have the single if else statement. Printf enter 5 integers. Write a scanf statement. Scanf. So percentage D, percentage D, percentage D, percentage D, percentage D. Yes. Ampersand A, ampersand B, ampersand C, ampersand D, ampersand. We need to write the max, find the minimum, right? Using nested if statement. So have another variable min. For example, I write a statement if A is less than B. Conveniently, I leave spaces for understanding purpose. A is less than C and A is less than B and A is less than B. I can write print of percentage D. That means the minimum one is A. Else if. So when A is minimum, right, these conditions, right, all these conditions are true. A less than B, A less than C, A less than D, A less than B. A gets printed. Otherwise, there will be a minimum in B, C, D, E. So we need to check if B less than C and E less than D and E less than E. Then print out percentage D. B is the minimum one. Else, if C less than D and C less than E, then print out percentage D. C is the minimum one. Else, if what needs to be checked, D and E. Else, if D less than E, the algorithm we have written, right? If the condition, then THEN, then we introduce it. That means if the condition is true, then execute the statement. Where in C language, right? Then right should not be used. So simply specify if with the condition. Print percentage D, sorry, percentage DS, okay. The D gets printed. Then else into percentage D, comma, finally return C. First, right, I have illustrated the usage of if else if statements, right? I tell you the syntax of if else if also now. If right takes a conditional part. If condition 1, say this is the first condition. This can be a simple condition or a compound condition, or we can have the simple relational expression or logical expression. This is ultimately a logical expression. Relational expressions, S introduced A less than B, A less than C, A less than D, A less than E. Logical AND operator is introduced, right? So logical and double ampersand. So clearly this is a logical operator, logical expression. If the highlighted condition results in true, this means A is the minimum, A is printed. Else if meaning is else if condition true. If the condition 2 results in true, this statement alone gets executed. Else if this is condition 3, condition 3 is true, this statement will get executed. Else if this is condition 4, the statement will get executed. Else, when all these conditions fail, condition 1, condition 2, condition 3, condition 4, ultimately the last else statement gets executed. That is the purpose of if else if statements, right? So to have multiple conditional expressions, conditional statements, conditions, and to execute a particular statement, right? We can have or we can use if else statement. Let us check the code, save CP22 F9, one error that we need to rectify the call to undefined function. Print, sorry, T is missed. F9, okay, control F9. Enter 5 integers, say 1, 2, 3, 4, 5. Minimum is at the first location. Yes, 1 is the minimum. Control F9. Say 2, 1, 3, 4, 5. Minimum is at second location. Right? Minimum gets printed. Control F9. 2, 3, 1, 4, 5. Minimum at third location. Verify. Minimum at the fourth location. 1, 2, 3, 0, 5. Fourth location 0. Fifth location 1, 2, 3, 4, minus 1. Minus 1 is the output. So, wherever is the minimum, which are occurring at first, second, third, fourth, and fifth locations, the code produces the correct result. Thus, you need to understand that if else if right, this is a conditional control statement. This takes the general form if condition 1 statement 1, else if condition 2 statement 2, else if condition 3 statement 3, else if etc., else if condition n statement n, else statement n plus 1. Upon the execution of a particular condition, if it results in true, then the specific statement or the block of statements will get executed. To have a block of statements, you need to enclose it in opening and closing curly braces. If when all the conditions result in fail, ultimately the final else block, final else statement will get executed. That is the logic of if else statement, right? So just have an idea how do we define if else statement, if else, if else, if else, if else statements. Right in the program. In the next session, we focus on what are control statements, conditional control statements, unconditional control statements. The examples under these for if, for, while, do, while, switch, break, exit, go to, continue, return the statements. Have any doubts in this session?
Sir, in Python, else if statement is written as elif statement, no, sir. Like that, we can write
Yeah,
here.
yes. No. That depends upon the language. Here in C language, else it should be written like this: else space if. If you leave the space, eliminate the space, this results in error, compile time error.
Okay, sir.
Then please wait for a few minutes. I save the recording and I tell you how to upload your assignment questions. Please wait.